Okay, students, I'm again with you for the solution of set B. Set A solution already I have shared with you. Now I'm doing it for set B. Not all the questions are different, only the few MCQs are different, and 2 or 3 questions in subjective, these are different. Okay, so starting with the first one in MCQ. A current carrying loop is placed in a uniform magnetic field. Okay, the torque acting on it does not depend upon the. So an expression for the torque experienced by a current carrying coil. You know now, moving coil galvanometer. The formula is B I N A sine theta or cos theta, whatever it is. Okay. So area of loop, yes, it depends. Value of current, it depends. Shape of the loop, no, it does not depend because it depends on magnetic field also. So option C is correct over here. 2. Kirchhoff's first and second laws of electrical circuits are consequences of first law, the conservation of charge. Second law, conservation of energy. Okay, option A is correct over here. A point charge is placed at distance d from an isolated conducting plate. This is isolated conducting plate. This is plus Q. So electric field will come out of this positive charge and will enter perpendicular to this plate. So here it will be negative, due to which this phase, opposite phase, will be positive. So now electric field will come out of it like this. So directed perpendicular to the plane and away from the plane. Yes, option A is correct over here. Fine. So now question number 4. Two charges are at distance d apart in air. These are the charges, distance d. Coulomb force between them is F. Fine. If a dielectric material of dielectric constant K is placed between them, the Coulomb force now becomes upon K. The force always reduces. Option A is correct over here. Question 5. In a coil of self-inductance 5, rate of change of current di by dt 2, and that is same. It was same in set A also. Now question number 6. In AC circuit, resonance will take place when inductive reactance is that is equal to the capacitive reactance. Option D. 7th, what is the relative refractive index of water? That is also same, less than unity. Same means similar to set A. A circular coil of that is also same. Option C. This is same, 6199. Now 10th is a little different. 3 capacitors each of capacitance 4 are to be connected in such a way that the effective capacitance 6. So what we will do, 2 should be in series. So 4 and 4 will become 2, and then 1 in parallel. So 2 plus 4, 6. So 2 in series, 1 in parallel. Option D. Question number 11. What happens to the frequency and the wavelength? That is also similar to set A. 12th is different. In different shapes, within the different shapes, the same charge has been kept, plus Q. So what about the flux? Flux will be same for all the figure. Option D. Reason assertion might be same as set A. Total charge, yes, this is same. Option C. Second, 14. The magnetic pole of a magnet can never be separated. Yes, this is true. Every atom of a magnetic substance is a complete dipole. That is option A. Both are correct. And reason is the correct reason for this assertion. 15. In series LCR resonance circuit, the impedance is equal to the ohmic resistance. True. At resonance inductive reactance, yeah, this is C. Means this is similar to set A. That is also similar to set A. All have given the mark, 1 mark, because this is wrong. Okay, so next question number 18, that is different. A cell of EMF 4 volt and internal resistance. So EMF E is given, internal R 1 ohm is given, DC source 10 volt. So what will happen to the net EMF, net voltage? Because it is being charged, so that will become 10 minus 4 means 6 volt. External resistance 5 ohm. Calculate the terminal voltage during charging. So first of all we should find current. I equals to E. E means net E. 6 by R means net R. 5 plus internal 1 means 6 by 6 means 1. So terminal potential difference E plus IR. E this time 4 volt plus I1 small r 1. So that is 5 volt. Then choice E1 R1, E2 R2, direct formula based. Calculate the EMF. An expression for net EMF E1 R2 plus E2 R1 divided by R1 plus R2. And net internal resistance R1 R2 divided by R1 plus R2. So net internal resistance will come out to be equal to 0.12 ohm, and EMF was equal to, that is approximately, if you put all these values, just calculate it. So 1.5 multiplied by 0.3, 2 multiplied by 0.2 divided by 0.3 plus 0.2 means 0.45 plus 0.4, 0.5 means 0.85. So that is 1.7 volt. That was the answer. Okay. Next, 19th same, 20th same, 21 same, 22 same. That was also same, 23. Yeah, that is different, 24. In the set A, this was for the spherical refracting surface, but here it is for the mirror. Mirror formula you need to derive. So a complete diagram when the object is beyond C. Okay. So complete ray diagram will give you 1 mark, and then 2 marks for derivation. And the choice, term critical angle and total internal reflection both 1 mark, 2 necessary conditions 1 mark, and relation 1 mark. Whether you give practical applications or not, you will get 3 marks up to here. Okay. Then 25th same. Yeah, 26th different, and figure is given just to confuse you. No use of figure. So number of turns in the inductor is reduced. So inductor having self inductance mu naught n square al. So when n is reduced, L will be reduced. L is reduced, impedance will be reduced. Means opposition is reduced, so current will be increased. So brightness will increase. Brightness of the bulb. Iron rod is inserted, so now L self inductance will increase. So current will decrease. So brightness will reduce. And when XC is equal to XL, so Z will be equal to R only. So current will be maximum. So brightness will be maximum. Means will increase. Okay. Now 27 same, 28 same. All others are same. So that is the solution of set B also. Thank you.